Welcome, ladies and gentlemen, to this video lecture. Let's take a look at this example. Determine the fifth Taylor polynomial of sine about 0 to determine the approximation P5(1) for the sine of 1, and show that this approximation P5(1) is within a 1 over 720th, or is within a 720th of the actual value of sine of 1. Okay, so let us determine the fifth Taylor polynomial of sine. So let's determine P5 of sine about 0. Okay, so what do we know? Let us define f of x as sine x, and now let us determine the derivatives of f. So the first, so f of x is sine x. First derivative of sine is cosine. Second derivative is minus sine. Third derivative is minus cosine. Fourth derivative is sine, and the fifth derivative is cosine. And we want the fifth Taylor polynomial about 0, so we are interested in the values of these derivatives at 0. Okay, let's compute these derivatives at 0. This is 0, that is 1, this is 0, this is minus 1, this is 0, and that is 1. So the fifth Taylor polynomial of sine about 0 is equal to 0 plus 1 x minus 0 plus 0, third term is 0, minus 1 over 3 factorial x minus 0 cubed, from there, plus 0 plus 1 x minus 0 to the 5 over 5 factorial. So here is the fifth Taylor polynomial. So let's just simplify a little bit. This is minus 1 over 3 factorial x cubed plus x to the 5 over 5 factorial. So here is our fifth Taylor polynomial about 0 of sine. And let us work out an approximation for sine of 1, which is equal to, so if we just plug in 1 here for the x, what do we get? 101 over 120, which is 0.8416. Repeating. So here we have an approximation for the sine of 1. So the sine of 1 is approximately equal to P5 of 1. Okay, so this is the first part of our question. And now we want to, in the second part of our question, show how accurate our approximation is. But we will do that in the next one. I will see you in the next one.